In this topic, we'll build the Active Directory domain that everything else depends on. You'll deploy ADDS in Azure, create the domain structure, join servers and clients, and validate the environment so it's ready to host an enterprise certification authority. You've already done the heavy lifting. You understand PKI fundamentals, and you've built the Azure Lab environment we'll use. Now we're shifting to the directory foundation. We'll start by building the Active Directory domain, then move into key PKI design decisions before installing enterprise SKAs. Active Directory is the foundation that makes an enterprise PKI manageable at scale. The CA doesn't maintain its own identity system. It reuses domain accounts, computers, and groups as certificate subjects. Certificate templates live in AD, so you can centrally define who gets which certificates and for what purpose. Group policy then distributes trusted routes and enables auto-enrollment, so users and devices receive and renew certificates automatically without manual requests. Our lab domain is the backbone of everything we'll do in this course. The domain controller runs both Active Directory and DNS, so every machine uses it for name resolution and authentication. The CA server issues certificates that are trusted because they're integrated with the domain. The IIS server requests those certificates to enable TLS, and the Windows client lets us test logons, certificate enrollment, and how trust flows end-to-end. Before we install ADDS, we want this VM to be boringly predictable. Give it a clear permanent name, like DC01, so logs and tools always reference it consistently. Assign a stable private IP in Azure, not a changing dynamic address. DNS is critical. Verify what it uses now and what it will use after promotion. Also confirm Windows updates, reboots, and that you have reliable administrative access. The first hands-on step is adding the Active Directory Domain Services role to your server. You can do this through Server Manager's Add Roles and Features wizard, or with PowerShell using Install Windows feature. Include the management tools so you can administer AD from this machine. After installation, the binaries are present, but the server is still just a member server. Verify the role installed cleanly. That prepares you for the separate promotion step. With the ADDS role installed, the next step is to promote the server to a domain controller and create a brand new forest. Treat this forest as the security boundary for your entire lab. Choose a DNS name used only internally, like corp.contoso.local, and install DNS during promotion, so clients can resolve that domain. Set a strong directory services restore mode password. This is your emergency backdoor if the directory ever needs offline repair. After promotion and reboot, think in terms of trust, services, shares, and health. Log on and confirm the machine authenticates as a domain controller, not a standalone server. Open tools like Active Directory users and computers, and DNS Manager to verify the domain and records are visible. Browse to the SYS-Vol and Netlogon shares to ensure they're accessible. Then run quick health checks so you're not adding more servers on top of hidden issues. Active Directory depends completely on DNS. When Client 01, CA 01, or Web 01 needs a domain service, it doesn't magically know where to go. It asks the domain DNS server. Add integrated DNS stores, SRV records like ledepgov, star-store, TCP, DC_MSDC's domain, plus host records for DC01, CA01, and Web01. Those SRV records tell clients which server to contact for logons, LDAP queries, and later, certificate enrollment. If clients use external DNS instead, they can't locate these services, causing domain join, authentication, and enrollment failures. Think of your OU design as the foundation for every certificate action you'll automate later. We separate servers, clients, users, and PKI admins, so policies can be tightly scoped and low risk. CA and IIS servers live in server OUs, letting us apply stricter security and PKI-specific settings. Clients and users get their own OUs to support auto-enrollment. The goal is simple: clear boundaries, easy targeting, and a lab that feels like a real enterprise. To properly test your PKI design, you need two things: realistic user identities and tightly scoped admin roles. Create normal test users who request and use certificates just like real employees. Then create PKI-specific groups, such as CA admins and certificate managers, and assign permissions to those groups instead of to domain admins. Use clear, consistent names so you instantly know who can enroll, who can manage, and who can review logs. Each of these lab machines has a very specific job. The CA server will become your enterprise CA, issuing certificates and publishing templates into Active Directory. The IIS server will request a web server certificate, bind it to HTTPS, and let you see how TLS really works. The Windows client lets you test auto-enrollment, trust chains, and revocation. Placing their computer accounts in the right OUs ensures the correct certificate and security policies apply automatically. Once the domain controller and DNS are working, the real test is joining the rest of the lab machines. First, point each server and client to the domain controller as their only DNS server. Then join CA01, WEB01, and Client01 to the domain, using a domain admin account when prompted. Reboot each system, so group policy and computer accounts apply. Afterwards, sign in with a domain user to confirm authentication is handled by Active Directory. Before you build PKI on top of your domain, prove the basics work. Confirm each lab machine has a corresponding computer object in Active Directory. Verify DNS can resolve domain controllers and the domain name using tools like NSLookup. Actually log on with a domain user account. Then run gpupdate and ensure group policy refreshes without errors. If any step fails, fix it now, before installing ADCS. You've now built the core: a healthy domain controller, working DNS, a structured OU model, and realistic users, groups, and computers. Your CA's IIS server and clients are domain joined and ready. Next, we'll design the Enterprise PKI itself, its hierarchy, naming, placement, and operational approach.